Right now, let's focus on a common and familiar imperfection, which is defocus. We have all experienced defocus when a camera struggles to lock onto a subject or when our own eyes lose their sharp focus. Let's explore what's happening behind the scenes. So, as previously, let's make an experiment. Let's take some sort of optical system made out of converging lens. Let's say that focal point of the system is located at some distance f, which should focus light perfectly on a sensor. Let's say that we have an object located on the right from our optical system, which would emit perfectly without any defocus image to the sensor. Lens would focus this image to the sensor. Lens would focus this object to the sensor. Well, let's say right now that we would shift the object from fixed position of the sensor to some distance delta z further to the left. What we observe, that focal point would shift, and therefore we wouldn't focus anymore straightly, perfectly to the sensor. This is what we call defocus. You can observe here on this image the focus, how it's observed on an image. So indeed, the focus is a translation of the focus along the optical axis, and PCF size increases, which introduce blur effects. So you can fix the focus by focusing back your optical system. So this aberration can be solved quite easily. So in summary, the focus occurs when the image plane doesn't align with the actual focal plane. So as that diagram illustrates, the focus essentially a translation of the focus along the optical axis. The light rays from a point on the object no longer converge to a sharp point on the sensor, but spread out into a blurred circle. The size of this blurred circle increases the focus, and the focus becomes more severe. This leads to characteristic blur appearance of the focused images. Well, what can be cost of the focus? In cameras and microscope, the focus can happen if the lens is not positioned correctly relative to the sensor. In our eyes, the focus occurs when muscles controlling the lens shape fail to adjust it properly for different viewing distances. This is why we can't focus on objects that are too close or too far away. The focus can be caused by other aberrations, like spherical aberration, which can also contribute to the focus. Well, consequences of the focus: blurred images, as you can see here, reduced contrast, and well, how to correct the focus is to refocus our optical system.